Few factory processes look as intense as this one. It takes nearly 3 hours to assemble 6 steel mold panels, each weighing over 1,000 pounds, into one giant mold. Then come the vents, the color pigment, and nearly 2 tons of polyethylene powder loaded bag by bag. After that, the mold is heated for hours under an open flame. When the smoke finally clears, it becomes a plastic tank that can hold 50 tons of liquid. To prevent leaks, weak spots, or dangerous pressure failures, this tank is made from polyethylene, formed through a high-temperature molding process. The steel structure outside is not the tank itself, but the mold. First, 6 heavy steel panels are brought together to form a cylinder about 8 meters long and roughly 3 meters across. Those measurements match the size of the finished plastic tank. Workers secure the panels with rows of bolts. Years of hands-on experience allow the 2 workers to move with impressive speed and coordination, but with bolts placed about every 10 centimeters. There are more than 80 fastening points in total. That means the workers must lift and adjust the heavy steel mold section, then position as much of it as possible onto a motorized roller system. Once it is set in place, the mold's edge rails press firmly against the rollers. From there, the motor helps rotate the mold, while the second round of tightening is completed. The method may look old-fashioned, but with a diameter of more than 3 meters, there is no practical way to tighten every point at once. Whether working along the lower rails or beside the rotating wheels of the heating station, the crew keeps adjusting the mold from every angle. So what does the inside look like at this stage? When the camera moves closer, we can see the mold is still completely empty. The inner surface is smooth and clean. There is nothing unusual inside yet. The real transformation begins with the powder poured into it. These white bags each contain 25 kilograms of polyethylene powder. This is the raw plastic material. Then another material is added, a light yellow color pigment. It may look pale and ordinary right now, but once it is mixed and exposed to high heat, the plastic begins to change. Eventually, the whole tank takes on a deep orange-yellow color. You may have noticed that the amount of plastic here is far greater than the amount of pigment. The color powder is only a small part of the mixture. The key is getting the ratio exactly right. If the proportions are even slightly off, the finished tank will not have that strong, uniform orange-yellow finish the tank being made today. Also needs to be sealed at both ends, with each bag holding 25 kilograms. About 80 bags are needed for this single tank. To keep production moving efficiently, the workers prepare the raw materials ahead of time. That yellow hopper helps move the blended material more efficiently. Next, the mixed plastic compound is carried into the workshop in batches. Workers line it up with the inspection opening and pour it directly into the mold. One important detail is this: the full 2 tons of plastic are not loaded all at once. Instead, they add the first portion, wait until it begins to soften and partially melt, and then add the second batch. This staged loading helps create a stronger bond. So can they start heating right away? Not until the threaded fittings are installed. These threaded sections become sealing points on the tank. Look closely here. The steel plate the worker is cleaning has a toothed ring built into one side because of the camera angle. We cannot see every detail of the thread pattern itself. To hold it in place, 6 screws are tightened around the outer edge. Once all the preparation is complete, the heating process can finally begin. For the workers, these next 2 hours are anything but easy. The situation here is intense from the very start. To avoid interruptions, a custom modified heating torch. Its fuel supply is designed to keep the flame burning continuously for up to 48 hours, but the flame temperature cannot stay the same throughout the job. At the beginning, the workers need a strong, concentrated heat. The steel mold is more than 5 millimeters thick, so it takes serious heat to bring up the temperature. At the same time, the plastic powder inside must begin melting onto the inner wall. During heating, the front end of the mold tilts at set intervals. Once the center section is hot enough, the heating shifts toward the base. Gravity helps the softened plastic slide down to the lower end. As you can see, this work depends heavily on timing and experience. Beyond timing, there are other changes the workers must watch carefully. The first thing anyone notices is the harsh smell rising from the heated plastic. Even clean polyethylene releases smoke and odor once it is exposed to this level of heat as the process continues. The air around the mold grows heavier. The good news is that inside the mold, the plastic has begun sticking to the steel wall. The first layer may still be thin, but it is enough for the second batch of plastic to be added during the 2-hour heating cycle. Material is usually added once at the beginning and once again around the middle for the rest of the time. The workers move back and forth, guiding the flame. Only when all the loose plastic has melted and formed a continuous inner layer can the workers bring the heating stage to an end. Drenched in sweat, they finally press the stop button. After that, the crew can take a short break. The freshly molded plastic has not fully hardened yet. If they force it out too early, the tank could deform or stretch. So the workshop leaves the tank to cool for about 2 more hours. Once the cooling time has passed, workers insert a pry bar. Then they use controlled force to loosen the metal plate. This first plate is usually the hardest part to remove. Around the outside of the plate, the circular teeth have now shaped the threads in the plastic. Next, a small blade is used to cut along the edges. This section will later serve as the tank's dedicated lid. Compared with other fastening methods, this threaded design is a classic and efficient solution for large tanks because it's molded as part of the structure. There is less risk of cracking or loosening over time. At the same time, the workers attach a lifting strap to the overhead crane. The front circular frame is also pried loose. The first stage of disassembly is often more difficult than it looks. So the workers reach for a sledgehammer. They strike carefully along the inner edge until the stuck lid section finally breaks free from the mold. Because the lid surface is smooth and curved, the finished tank needs very little extra finishing before it is ready for use. So how do they remove the plastic tank from inside the steel mold? More importantly, how do they pull it out without damaging the tank itself? The method is surprisingly simple. First, a steel rod is inserted through the lifting hook. The rod is positioned securely inside the opening. When the crane pulls outward, the tank slowly slides out of the steel mold. The opening may bend slightly under the pulling force, but plastic can recover better than metal. So the workers do not have to worry about damaging this 2-ton tank. If you look closely, you can see intersecting marks across the tank's outer surface. These marks come from the seams of the steel mold panels. A tank this large is simply too big for a single-piece steel mold. After heating and molding, not counting what it can hold inside, the tank itself weighs about 2,000 kilograms. Its internal capacity, however, reaches 50 tons, whether filled with water or methanol. It can hold around 50,000 kilograms of liquid. So how large is it in real life? At least 3 workers can stand side by side on land. From end to end, it stretches a full 8 meters.